Beneath Yellowstone National Park, a patch of ground the size of Chicago just took a deep breath. That is not a metaphor, it is a measurement. Between July and December of 2025, GPS stations tracked a 19-mile wide section of the Earth known as the Norris Uplift Anomaly as it rose a slow, steady 1.5 centimeters. It swelled upward silently, driven by forces miles below. And then, in early 2026, it stopped. The ground is literally breathing, and everyone knows what lies beneath that breath. A supervolcano, a machine of continental scale, capable of devastation so profound it exists beyond our modern comprehension. But the story you have been told about that volcano, about how it works, about the threat it poses, is being completely rewritten. The real danger in Yellowstone isn't the one you see in disaster movies. It isn't the global apocalypse. It's smaller, it's more frequent, and it is already happening. At 5:09 in the morning on June 13th, 2026, a bomb went off in Yellowstone's Biscuit Basin. It was not volcanic. No magma was involved. It was water. Superheated and trapped, it flashed to steam with unimaginable force, tearing a 61-foot-long boiling fissure in the earth. It happened with no seismic warning, no countdown, no chance to evacuate. This isn't a prediction. It is a bulletin from the front line of a geological war. So the real question is, what is actually happening miles beneath the surface of America's most volatile landscape? Because everything we thought we knew might be wrong. Yellowstone does not operate on a human timescale. It is a place of deep time, of forces that measure their progress in millennia. The last super eruption, the event that formed the vast caldera we see today, happened 631,000 years ago. Geologists look at that number. They look at the two previous cataclysms, stretching back 2.1 million years, and they do the math. They draw a line between three data points and declare the volcano is overdue. It is a comforting, linear story. It is also almost certainly false. Volcanoes do not run on train schedules. And as Mike Poland, the scientist in charge at the Yellowstone Volcano Observatory, constantly reminds us, the caldera is not a ticking time bomb. It is a living, breathing system. That Chicago-sized uplift at the Norris Geyser Basin, it's not a prelude to an eruption. It's a symptom of the volcano's pulse. As he puts it, saying the uplift is the size of Chicago makes it sound incredibly grandiose. That doesn't mean that the volcano is about to erupt. It's Yellowstone being Yellowstone. The ground rises and falls all the time. The movement is almost always driven by water. Hot water, gases, and bizarre hydrothermal fluids moving through a subterranean labyrinth of cracks and fissures. Think of it less like a balloon filling with magma and more like a waterbed sloshing around. This is the normal state of things. The rise in late 2025 was just the most recent, most well-documented breath in a cycle that has been repeating for centuries. It followed a decade of subsidence, of the ground slowly falling. But to say this is normal is not to say it is safe. Because the true, immediate threat in Yellowstone is not the magma chamber miles below. It's the water trapped just a few hundred feet beneath your feet. What happened in Biscuit Basin on June 13th, 2026, was not a volcanic event. It was a hydrothermal explosion. And it is a far more immediate, unpredictable, and personal danger. The physics are terrifyingly simple. Water percolates down through the crust, where it meets the immense heat radiating from the magma chamber. The pressure of the rock above keeps it in a liquid state, even as its temperature soars past 250 degrees Celsius, more than twice the boiling point of water. It becomes a liquid bomb. All that's needed is a trigger. Over time, minerals in that superheated water precipitate out, clogging the underground plumbing like cholesterol in an artery. The pressure builds and builds until a weak point gives way. The water instantly flashes to steam, expanding to over 1,500 times its original volume in a fraction of a second. The result is an explosion of pure physical force. It blasts rock, mud, and boiling water hundreds of feet into the air. This has happened countless times in Yellowstone's past. The park is littered with the craters of ancient hydrothermal blasts. But on July 23, 2024, at 10 in the morning, it happened in a developed area, right next to a visitor boardwalk. The explosion at Black Diamond Pool was so violent it tore the walkway to splinters, hurled boulders across the landscape, and forced the National Park Service to close Biscuit Basin. Permanently, 0 casualties, but only because of sheer luck. It was the first sign that the system's character was changing. Then, less than 2 years later, it happened again. The June 2026 event was different. It happened at 5:09 a.m. in the pre-dawn darkness. It was larger, ripping that 61-foot fissure in the ground and creating a brand new, furiously boiling pool where solid earth had been just moments before. Days later, that collapsed pool began spouting water 20 to 30 feet into the air. The plumbing of the basin had been catastrophically rerouted in an instant. This is the new reality of Yellowstone. Not a singular, telegraphed supereruption, but a landscape pockmarked with hidden pressure cookers that can detonate at any moment, with absolutely no warning from the park's vast network of seismometers. These are not geological events. They are geological ambushes. And the question that haunts scientists at the EVO is not if it will happen again, but where. Because beneath the surface, the entire system is in flux. And the very engine driving it all is now the subject of one of the most profound scientific debates in modern geology. For decades, the origin story of Yellowstone was settled. We had a theory. It was elegant, powerful, and it explained everything. The theory was called the mantle plume. Imagine a blowtorch of unimaginably hot rock. A column rising vertically all the way from the border of the Earth's core, 1,800 miles down. This plume is stationary. But the North American tectonic plate is not. For 17 million years, the continent has been slowly sliding southwest over this fixed heat source. The result is a 500-mile-long scar of dead calderas burned into the crust, a trail of breadcrumbs leading from Oregon and Nevada, across Idaho's Snake River Plain, and ending here, at Yellowstone, the current location of the blowtorch. This model explained the heat. It explained the volcanism. It explained the geographical track of eruptions over millions of years. It was the foundation of our understanding, and it may be completely wrong. On April 10th, 2026, the journal Science published a paper that didn't just question the mantle plume theory. It proposed a radical new one. A team of researchers, led by Li-Jun Liu and Zeben Cao from the University of Illinois and the Chinese Academy of Sciences, built a new type of supercomputer model. They weren't just looking at the heat source. They were modeling the entire tectonic history of North America. And what they found changes everything. Their model points not to a vertical plume, but to a horizontal wind, a mantle wind. Here's how it works. Millions of years ago, as the continents shifted, an ancient oceanic plate called the Farallon Plate slid underneath the west coast of North America and began to sink into the mantle. It was subducted, but it didn't just melt and disappear. It kept sinking. Today, a huge, cold, dense slab of that ghost plate lies deep beneath the eastern United States. It's still sinking, and its immense gravitational pull is dragging the hot, soft rock of the asthenosphere, the upper layer of the mantle, eastward like a vast, slow-motion river of molten rock flowing sideways beneath the continent. According to Liu and Cao's model, this mantle wind is the true source of Yellowstone's power. As this river of hot rock flows eastward, it encounters the thick, ancient, and rigid chunk of crust that forms the core of the North American continent. The mantle wind is forced to squeeze through a thinner, weaker spot in the lithosphere. That spot is Yellowstone. The pressure and friction of that sideways flow generates enormous amounts of melt, which then rises to feed the magma chamber. The implications are staggering. Yellowstone isn't being fueled by a blowtorch from the planet's core. It's being created by the tectonic machinery of the crust itself. A sunken ghost plate on one side of the continent is pulling a river of fire across to the other, creating a volcano as a side effect. As Dr. Liu stated, our work changes the understanding of how the magma plumbing system works. So future eruption models have to take this into account. He is being modest. It means the story we've told for 50 years, the story of the fixed hotspot and the moving plate, might just be a convenient fiction. The truth is stranger, more complex, and woven into the very fabric of the continent itself. This new theory doesn't mean the danger is gone, it just changes its nature. If the magma source isn't a stable, vertical plume but a dynamic, horizontal flow, then its behavior might be far less predictable. The changes we see on the surface, the breathing ground, the explosive water, might be symptoms of shifts in that deeper, continental scale flow. The debate is now active and heated within the geological community. Many scientists still stand by the deep mantle plume model. It has decades of evidence supporting it, but the mantle wind theory explains certain anomalies that the plume theory struggles with. That uncertainty is, itself, a new kind of threat. We are flying blind into a new scientific paradigm, and the evidence that the system's deep plumbing is actively and aggressively changing is not theoretical. It's visible on the surface, every single day. You just have to know where to look. Go to the Norris Geyser Basin, the hottest and most dynamic thermal area in the park. For years, the main attraction here has been Steamboat Geyser. It is the world's tallest active geyser, capable of throwing a column of water over 300 feet into the air. A major eruption from Steamboat is a force of nature, a thunderous, primal display that can last for hours. Between 2018 and 2022, it was in a period of unprecedented activity, erupting dozens of times a year. Tourists flocked to see it. Scientists monitored it as a barometer of the entire basin's health. And now it's going quiet. In the entire year of 2025, Steamboat Geyser erupted just 3 times. That is not a gradual decline. It is a cliff. The pressure that drove its colossal eruptions has vanished. The water that fed it has gone somewhere else. The king of geysers is entering a dormant phase, its power draining away into the earth. It feels like the end of an era. But in Yellowstone, every ending is also a beginning. The park's hydrothermal system is a zero-sum game. The heat and water are finite. If one feature dies, it's because its energy has been rerouted to another. In early 2026, as Steamboat slumbered, a geyser named Equinus, not far away, roared back to life after years of near-total silence. Then, in June of 2026, something even more remarkable happened. Fan and Mortar Geyser, a complex and beautiful feature on the banks of the Firehole River that had been dormant for roughly 3 years, suddenly erupted. Weeks later, Giant Geyser, another celebrated feature that had not erupted since October of 2025, also woke up. This isn't random. This is a pattern. It is tangible proof that the underground plumbing network is actively shifting. The pipes are being reconfigured in real time. Old channels are being clogged by mineral deposits, while new fractures are being forced open by the relentless pressure. This underground migration of superheated water is what makes the hydrothermal explosion threat so potent. The system is unstable. A blockage that quiets a famous geyser in one location could be the very thing that builds the pressure for a catastrophic steam explosion a mile away. We are watching the system rewire itself, and we have no map of the new circuitry. Every dormant geyser, every new boiling mud pot, every tremor is a clue to where the pressure is moving next. The changes aren't just geological, they're biological. The forces reshaping Yellowstone's surface are also giving birth to one of the most alien ecosystems on Earth. Miles beneath the park, in a world of total darkness, crushing pressure, and scalding water, there is life. Vast, ancient communities of microbes that have evolved to survive in conditions that would instantly annihilate any surface-dwelling organism. For years, scientists wondered how they survived. What did they eat? The answer, revealed in a groundbreaking study in late 2025, is as strange as the organisms themselves. They eat earthquakes. A team of microbiologists led by Dr. Eric Boyd published their findings on November 25, 2025. They discovered that the constant swarm of microquakes that shudder through Yellowstone are the engine of this deep biosphere. In 2025 alone, the University of Utah seismograph stations recorded 1,136 earthquakes in the region. Most were too small for any human to feel. But underground, each one is a cataclysm. Each tremor fractures the rock, exposing new mineral surfaces to the hot water circulating through the crust. This interaction creates a chemical reaction, releasing hydrogen, methane, and other energy-rich compounds into the dark aquifers. For these deep Earth microbes, this is dinner. Each earthquake delivers a fresh chemical meal. It's a chemical menu change, as the researchers described it. A seismic event on the surface translates directly into a bloom of life deep below. It's a profound, clarifying discovery. The volcano is not just a destructive force, it's a creative one. The same tectonic stress that powers the geysers and threatens the surface is the very thing that makes life possible in the uttermost depths. We are standing on top of a secret, subterranean world that is powered by the planet's restlessness. A world where the ground shaking is not a sign of death, but the rhythm of life itself. So we are left with a series of unsettling truths. The ground beneath our feet is breathing, heaving up and down on a scale the size of a major city. The real, present danger is not a cinematic supereruption, but a string of unpredictable, landmine-like steam explosions that can happen anywhere, at any time. The very plumbing of the park is being aggressively rerouted, silencing giants like Steamboat while resurrecting long dormant geysers elsewhere. And our fundamental scientific understanding of what powers this entire system has been thrown into question by a new, revolutionary theory about a river of magma flowing sideways across the continent. This is not the Yellowstone of the tourist brochures. This is the Yellowstone that keeps scientists like Jamie Farrell, the park's chief seismologist, and Mike Poland awake at night. They are not tracking a single monster. They are monitoring a complex, interconnected system that is changing faster than our models can keep up with. Every data point, every one of the 1,136 earthquakes in 2025, every millimeter of ground deformation, every change in geyser eruption frequency is a piece of a puzzle that we are only just beginning to assemble. The real question is no longer if Yellowstone will erupt. The question is, what does Yellowstone even mean? Is it a single, localized threat contained within the park's borders? A legacy of a deep mantle plume about to burn itself out? Or is the new science right? Is Yellowstone merely the most visible symptom of a much larger, continent-spanning tectonic process? The mantle wind theory suggests the forces at play are not local. They are tied to the sinking of the Farallon Ghost Plate hundreds of miles to the east, and the slow, grinding reorganization of the entire North American crust. The underground changes are not isolated to Wyoming. They may be part of a system that is reaching across the West. We are seeing the surface effects, a 61-foot fissure torn in the earth, a new boiling pool born in an instant, a legendary geyser falling silent. These are not warnings of a coming apocalypse. They are dispatches from a planet that is alive, dynamic, and utterly indifferent to our presence. We built our parks, our cities, and our scientific certainties on a crust we assumed was stable. It is not. The explosions in Biscuit Basin are real. The uplift is measured. The new science is on the table, challenging decades of assumption. And deep beneath the tourist trails and the pine forests, a river of magma flows through the dark, its currents shifting, its destination unknown, driven by forces we are only just now beginning to comprehend. The clock is not ticking towards a single event. The entire landscape is being remade from the inside out.